So if this is concentration units, this is molarity to the 5/2 over molarity squared. So this is 2.5, this is 2, so it's going to give you molarity to the 1/2 power. It's just what you would get by plugging in the units for whatever thing you wrote in the equilibrium expression. If I multiply this by if I go to this one, I multiply it by a -2, so that becomes, notice I'm not putting in equal signs, it's because it becomes, whoops, right here. Because it's -2 times this, which makes it -1, so it's molarity to the -1. So this equation up here would have units molarity to -1, whereas this one down here would be molarity to 1/2. And if we just wrote this thing, it would be, I'm running out of space here, I'm going to get rid of this. Just looking at this thing, it would be molarity squared over molarity squared, I'm not getting the same thing. Molarity cubed. Somehow I multiply that. Let me look at this one again. 3/2 to the first, and, oh, no, this is 2/2, 5/2 over squared. This is 4/2, 5/2, 1/2. Now raise it to the -2 power. Okay, and that made it -1 up here. I got, oh, it should have different units because what? Different exponents. Okay. So did I do that right?
Yeah,
Let me make sure I got my
and 204.
sign here. Squared, cubed, squared, squares go out, so it's -3. So now I have to look at what I did here. I multiplied this by -2 to get up here, made it 2 and 2, 302. Somewhere I think I messed up my subtraction. Oh, I'm working with this equation. Yeah. Oh, this isn't squared here. Because I somehow, I was starting off with this equation. Okay. Oh, I know I got into the wrong problem. Let me get rid of that problem. I was looking at the wrong problem. Okay, so I was back, let me go back to this one. This was N2O to the first, O2 to the 3/2, N2O4. That's what the problem is. So I was looking at this thing instead of the equation I was doing. So now it's 5/2 over molarity to the first power, which makes it what? Molarity to the 3/2. Okay. And then when I multiply that to by -2, it makes it molarity, oops, 3/2. So it's -6/2, which makes it -3 going through all those operations, which is what I got by going in the other way. So all I'm saying is the units for the equilibrium constant are just what you would get by plugging in the units for the various things. If I were doing this with pressure units instead, this would be atmospheres to the -3 power. Okay? Or this other equation here, it would be atmospheres to the 3/2 power. So your book says, don't bother with units. Some other books, when you read them, make a big deal about putting in the units. The units are sort of trivial, and if you want to be really correct, as your book wants to be, you don't put units in because equilibrium constants in terms of activities or the corresponding activities of gases will be always dimensionless numbers. So your book follows that rule, so he doesn't bother putting in the units. But if you ever want to, you just put in whatever units you get by looking at the equilibrium expression. So that was just an aside. It doesn't have nothing to do with solving this problem, but sometimes when you're reading other books, you'll come across things and they'll expect you to put in units in the equilibrium constant. So coming back to this thing though, make sure I get the right equation, because I need delta n yet. So this is 2 minus 2 minus 3, so its delta n is a negative 3. Then I just get out my calculator, using parentheses and signs and everything so you don't mess up. You'll get the, did I forget something? 546, oh, what did I forget? Because this was case C right here for this equation.
For which equation?
One he asked me for.
Oh, okay.
This is the one he gave me. So I went from here to here by multiplying this equation by minus 2. So the case of C for this top equation, the one we're going to solve for, is 546 times 10 to the minus 4 to the negative 2 power. Yes?
How do you get 5.46 times 10 to a negative 2? Isn't it negative 4? To the negative
Oh. You're right, I didn't copy right. In other words, this was case of C for the equation that the book is asking me. Okay? And I got that because I went from this equation to this equation by reversing it. That's where the minus sign was, appeared from, and then I doubled everything. Okay. And you could get this number if you want, but I didn't really ask you for that number, so if you're doing the setup, this is the entire setup, and now if you can push the buttons in the right sequence and everything, you'll get the right answer. Let's see if I can push the button.